Hi everyone, this is Emily with the glycolysis, gluconeogenesis, and Aldolase gene expression presentation for week 8 for Chem 530 biochemistry. Just to go over a few things that are going to be in this presentation. We have glycolysis and gluconeogenesis pathways, how Aldolase is involved, and the different isoforms of Aldolase and Aldolase B expression. So just to go over what glycolysis and gluconeogenesis is, they are not a reverse of each other, although they look very similar. There are some differences. Glycolysis is a catabolic reaction, whereas gluconeogenesis is anabolic. They do both use similar inputs, but just a few differences, specifically in step 1, 3, and 10. So gluconeogenesis overview. Like I said, it's not the exact reversal of glycolysis, but it's pretty similar. It provides glucose by using pyruvate. This process begins after dietary glucose stores are used. It's an anabolic process, the opposite of glycolysis. It occurs in the liver and sometimes the renal cortex. 7 of the reactions are reversible, but 3 are irreversible, and these are the catalyzed by the hexokinase PFK1 and pyruvate kinase. So, Aldolase in the pathways, specifically, Aldolase is an enzyme that catalyzes reactions in both glycolysis and gluconeogenesis. So I have it circled over in the graph to the right. Specifically, Aldolase is found in multiple types of cells, including bacteria, eukaryotic cells, and archaea, different cells and organisms. And there are 3 separate classes of Aldolase: Class 1, Class 1A, and Class 2. Aldolase is often used as a drug or vaccine target. So specifically, the Aldolase isoform 1,6-biophosphate is the one used in the glycolysis and gluconeogenesis. It's also known as Aldolase B, or fructose biphosphate, or liver type Aldolase. It specifically catalyzes the cleavage of Aldolase B into glyceryl dehydrate 3-phosphate and dihydroacetone phosphate. It also catalyzes cleavage of fructose 1-phosphate into glycerolide and dihydroxyiron phosphate. So finally, the Aldolase transcription factors such as HNF1, HNF3, C, EPB3, EC, EPB, and DPB. These are just some things that will turn on or off, the genes that will turn on or off and help regulate aldolase and therefore the glycolysis and gluconeogenesis. Specifically, the HNF1 and DPB are strong trans activators, which means they are strong activators. They would increase the transcription of aldolase. CEPB, while it is a transcription factor and a little bit stronger, like it is a trans activator, it's more of a weak one when compared to HNF1 and DBP. Whereas HNF3 is an antagonizer, or it prevents the transcription of aldolase. This is because it binds to the same site as HNF1. So overall, glycolysis and gluconeogenesis are similar but different, but they both work with glucose or pyruvate. Aldolase acts as a catalyst for both of the pathways, and aldolase can come in different forms, or also known as isotopes. Some genes that we saw can increase transcription of aldolase, while others may work to inhibit. And these are my references, and if there are any questions or comments, you can reach me at my GCU email. Thank you. Have a good night.